So this review video for the calculator will be all things probability. Reminder, if you go to the back matter of your online textbook or go to the back of the hard copy textbook, you have tech reference corners here. So from 1 to 32, the page number for all of these things are listed, and they correspond when you are on Sapling under student resources to these TI-84 tech corner videos. So you can see which ones you need, 1 through 32, and take a look at those as well. So to work through all things tech related, all things probability related, you might have a hard copy of this Sudoku probability worksheet. If not, I would recommend printing it off and giving it a try. It is a tough one, but a good time. And so for each of them, the directions are to round your probability calculations as stated and then follow the directions to convert them from 1 to 6. This is like beginner Sudoku, only using 1 through 6. And then the answers A through R fall into that cell. So what's in italics there is what you need for however many problems follow. And so again, if you want to print this off and try on your own, I'd like to work through my answers for it. Now, pages 3 and 4 of this do have their answers, but mine has a few extra notes on it. So once you're done, we can look at answers. So here's what I have for my answer. So for part A, set up a little system there and solved. Didn't really need the calculator except for the actual calculations part of it. Combining random variables is my RVs, which is B and C. The average of the 4, just adding those 4 together. And then the rule for standard deviation is that we add variances, and then we have to go back and square root. So since it was the same standard deviation 4 times, it's actually the same variance 4 times. So 0.01 squared. So that should be correct on the document you're looking at, but a little typo there. And then D and E, we get to transformations. Just remembering what changes by what, since we were multiplying, it's 3 times as much. That multiplication affects both measures of center and measures of spread. So then here's where the calculator becomes a bit more useful. For part F, we're dealing with normal distributions, a mean of 7.7 pounds and a standard deviation of 0.7 pounds. So for F, we are looking at one randomly selected newborn weighing more than 9 pounds. You can find the z-score and get a z-score of 1.86, and then you could look the z-score up in table A and take 1 minus that answer to get the 0.0316, or you could use normal CDF in the calculator. So when you go to second distribution, this is where we find all these values. So my normal CDF asks me for lower, upper, mean, and standard deviation. I can enter these with z-scores if I want to, or I can enter the values from my problem, which was what I had. So I used a 9, and then something really far away was my 1 times 10 to the 99th. It doesn't have to be that big. You could use 100 or 1,000. You just don't want to clip this at the end. So our mean is 7.7, and our standard deviation was 0.7. So again, in the context of the problem doing this, we totally bypass the z-score. We never see anywhere that value of 1.86. We just go straight to the area from the table instead. This answer actually gets used in the next question. G is a binomial distribution, exactly 2 of the 8. So the formula is there with 8, choose 2. That option is under math probability on the calculator, that NCR, or we could use the binomial PDF. So if you wanted to write the whole thing out, again, under math and then probability is where we find the NCR. So it was of the 8, we're choosing 2 of them. and then multiplying that by each probability. So this again tells us there are 28 ways to choose 2 of the 8, and then we have 2 successes, and the other 6 being failures is what the rest of the formula represents. So that's all multiplication. Or we could go to second distribution, and all the way towards the bottom we have binomial PDF and CDF. So P is for a particular point, which is what we're trying to find here. So we had 8 trials. We had a probability of about 0.0316 from the previous part, and we're trying to find exactly 2 of them. So if we do binomial PDF, that would be if I had finished what I started up above with the 28 and multiplied it out the way it was written on the worksheet. This tells me that exact point for that happening. So the difference between PDF and CDF is that CDF tells me at or below whatever that particular value is that I enter in for X. So if I have 8 trials and a probability of 0.0316 and I enter that 2 again, this is actually going to find the probability of 0 of the 8 or 1 of the 8 or 2 of the 8 and add all 3 of those together instead. It was a small probability of it happening, so it's pretty reasonable that we don't have any 0 of the 8 or 1 out of the 8 would be more likely. So you see that big jump. So if you had done binomial PDF with the 8.0316 and 0, added it to binomial PDF of the 8.0316 and 1, added that to the binomial PDF of 8.036 and 2, then that gives you, I always think of the C as the cumulative probability. So it's finding all 3 of those. We need to do that if you look at the little extra note that I made off to the side. So if we need the CDF, it's just at or below, like I had just explained, or it could be something where we're trying to find what is to the right instead, what is more. So the probability that X would be greater than 2 would be that 3, 4, 5, 6, 7, or 8 of the randomly selected babies weigh more than 9 pounds. That's an awful lot to add together. So the shortcut is to take 1 minus what's not included, which would be less than or equal to 2, which would be the binomial CDF that I just worked out. If it is greater than or equal to 2 instead, 2 is included in my answer, which means I'm subtracting off only 0 and 1. And so the binomial CDF would use 8, 0.0316, 1. And that's what the P of X is less than or equal to 1 means. So because these are discrete, because I can count the number of newborn babies from 0 to 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, it matters whether or not they're included. So you have to pay close attention to whether or not it is greater than, less than, at least so much, all that language to know which values are included. The next couple, I included some more notes here for H. Those were the formulas for combining random variables. We saw them up above, but we struggle a little bit when we end up with that difference of 0. So since the 2 are the same, 7.7 for both, I end up with a difference of 0. Standard deviation, again, I find by adding the variances together. I entered that as a formula when I did normal CDF. This is actually one of the best uses of normal CDF, which I just abbreviated to NCDF. And that's because if we did this by hand with z-scores, if you look at the bell curve over on the left-hand side, you'd have to find both z-scores, or find one and just take into account the other tail, since in this particular case that they're just as far away. But it's nice that lower and upper, it doesn't have to be the tails. It can actually be between 2 points on your curve to find that answer. I deals with the central limit theorem. So again, the z-score formula could be used, and this time the x bar minus mu is divided by sigma over the square root of n, because I have to take into account sample size when I'm talking about if the average is going to be between those values. And so this one, again, perfect example. This one's not as far away on either side. 7 is farther from 7.7 than 8.2 pounds would be. Standard deviation, 0.7 is divided again by the square root of 4. You can key all of that right into the calculator to get straight to the answer. Jumping back to my geometric and binomial probabilities, we have here no fixed number of trials. That's what makes it geometric. And so he fails on the first 3, or I should say the machine fails. He doesn't fail. The machine fails on the first 3, and it's not a fastball. It's not a fastball until we hit the 4th trial. So since this is happening on the 4th ball, I would use the geometric PDF, very similar to binomial. So still under second distribution. This one's just even closer to the bottom. PDF finds an exact point. PDF finds an exact point. CDF finds accumulation of points. And for geometric, there's no fixed number of trials. And so I don't have an N. I just go straight to the P, which was 0.78. And my X, I was looking at the 4th ball being the first time we saw that. So this, again, I feel like these are easy enough because it's a string of failures and then that success. So P again is just on the 4th ball. So I fail 3 times and then I get it on the 4th. And CDF would be accumulation of them. So for K, I showed how that would work. If the first fastball comes after the second pitch, it's not on the first pitch, it's not on the second pitch. So instead of calculating those individually, geometric CDF finds those and adds them together for you. So still 0.78, 2 or fewer. Geometric, again, is a little different. There's no 0 because we have to have some outcome so that we can say whether or not it was success or failure on the first one, but then there's also no end. And so to figure out after the second pitch, you would be taking 3rd plus 4th plus 5th plus 6th all the way through. So it's really just recognizing that it's not happening on the first or second one. The last calculator piece, excuse that flip, the last calculator piece, we just had a little bit of multiplication in these next 2, would be inverse norm. This was a tremendously valuable one. This was the one where we would have to work backwards in the calculator instead. So the top 15% is actually the 85th percentile. And so inverse norm will work backwards and either give you the z-score or the value in the context of the problem. So for N, I found the z-score that corresponds to the top 15%. The 85th percentile that would be is 1.036. And this on the calculator is under my distributions menu as well, number 3. And so asking you the area, mean and standard deviation are defaulted to 0 and 1 because that's going to kick back a z-score for you. In this one, I was working backwards. Instead of finding the 322, which is the value that corresponds to that top 15%, I had to find standard deviation. A lot of the problems we've had were given mean and standard deviation, and it's that particular value we're trying to find. And so that's the instance where in the calculator you can enter mean and standard deviation instead. Okay, so again, instead of that 0 and 1 in the context of the problem. So just to recap, under the distributions menu, we love number 2. Normal CDF gives us the probability instead of using table A. Inverse norm, number 3, we love even more. That works backwards from the table. We didn't look at inverse T or TCDF. They essentially function the same for us as inverse norm and the normal CDF. So it can either in the T distribution give you the probability or that critical value that's there. And then at the bottom, binomial C and PDF and geometric C and PDF, where again, the PDFs are a particular point and the CDF is like a bunch of PDFs added together.